There are two natural ways to define the projection of one vector onto the other vector. So the scalar projection only cares about the length and the sign. It is the sign length of the shadow of u onto the direction of v. If the angle between u and v is less than pi over 2, then the scalar projection is positive. If the angle is greater than pi over 2, then the scalar projection is negative. The scalar projection is equal to the norm of u times the cosine of the angle between u and v. And remember that we can compute cosine of the angle using the dot product. Cosine of the angle is equal to the dot product of u and v over the product of the norms of u and v. And in the formula, we can cancel out the norm of u here. And the scalar projection is equal to the dot product of u and v over the norm of v. There's another way to define the projection, which is the vector projection. Now, instead of a real number, we define it as a vector. This vector has the same direction as v if the angle between u and v is less than pi over 2. If the angle between u and v is greater than pi over 2, then it has the opposite direction with v. So the vector projection is equal to the scalar projection times the unit directional vector. It is the product of the dot product of u and v over the norm of v and v over the norm of v. So it is dot product of u and v over the square of the norm of v times v. And we know that the square of the norm of v is equal to the dot product of v and v. So the final result is the quotient between dot product of u and v and the dot product of v and v, then multiplied by v. So in the quotient, the products are dot products, and the final multiplication is the scalar multiplication. Now let's do an exercise. We want to find the vector projection of 1, 2, 3 onto 1, 1, 0. We can just use the formula in the vector projection. The dot product is equal to 3, which is 1 plus 2 plus 0. And the dot product between v and v is 2, is 1 plus 1. And the vector projection is equal to the quotient, which is 3 over 2, times v, which is 1, 1, 0. And the multiplication, it's a scalar multiplication. It's 3 over 2, 3 over 2, 0.